Okay, y'all, this is just a vocabulary day. Once we get through a few terms that I'm not going to waste a lot of time on for you, you can go and you'll see the one problem we're going to work out. You're going to work out a one for yourself. This is a day to just solidify your knowledge. Okay, so first, when we talk about solutions to quadratics, okay, first thing we do is talk about solutions to quadratics. And when we talk about the solutions to the quadratics, what we're really talking about is where we cross the x-axis. See how these are crossing the x-axis? So even though it's not out here, I'm going to read it to you. It says, where the parabola, that's the shape of the graphed quadratic, crosses the x-axis, we find our solutions. And now this is where it's going to get a little confusing for you. Okay? Each of the following terms that I'm going to give you is one of the ways you can identify solutions for a quadratic equation. Okay, one is we call them x-intercepts. Two, we call them solutions. Okay, three, we also call them roots, because if you notice, it looks like roots that go underground. And the last way we call them x-intercept, solutions, roots, and we call them zeros, because these are found. A quadratic will look something like this. Y equals x squared plus 3x plus 2. Okay? And when this y is 0, that is where we're crossing the x-axis. And that's why we call them roots or solutions. I want you to notice in the graph above, the far graph on the left, it never touches the x-axis. Okay, this graph touches the x-axis in exactly one spot, and this touches the x-axis in two places. Over here, notice it says no solutions. When we do not touch the x-axis, we actually have no real solutions. And in later courses, you're going to learn about what we call imaginary numbers, because these will have roots or solutions, but they're imaginary. And they come because we have to divide by a square root of a negative number, something we don't have to worry about right now. This one right here, the one solution, we call that a double root. And we'll explain why it's a double root here in a little bit. Just know that this is a double root. This has two imaginary answers. This has two of the same answer. And of course, this has two solutions, and they're both considered real numbers, two real solutions. Okay. One of the other things we need to work on identifying is the vertex. The vertex is the absolute bottom, or if we had a parabola that looked like this, the absolute top is called the vertex. And the vertex is pretty important. It tells us a bunch of things. It's not just a dot that's in the middle of something. For instance, if our vertex was at 2, -0, we're right here. If our vertex was at 2, -0, we can identify some of our vocabulary terms that we have. The first one is axis of symmetry. So let me draw a parabola down here, and I'm going to draw it really neat around the y-axis. Notice how this is mirrored across the y-axis. It's the exact same over here, just flipped over here. And we call the line right through the middle that goes right through the vertex the axis of symmetry, because that's the line that it reflects across. Now, when we have -2, 0 for a vertex, notice I'm going to do nothing more than write x equals -2. If I literally just write x equals -2 from what I see at the vertex, I have actually written the formula for the axis of symmetry. It's pretty simple. Okay. Now, to have a vertex at -2, 0, I'm going to sketch what that kind of looks like a little bit for you. -2, 0. Right? In this case, let's say the parabola is doing this. Notice that all the y values start at 0 and go up. Notice that the y value at the vertex is 0. So if we write y and 0, because y is 0 at the vertex in this particular case. And we notice that what touches 0 and it's all the values above it, this now creates our range for us. So the axis of symmetry is nothing more than writing x equals whatever x is at the vertex. And the range is either going to be y is greater than or equal to the y value here, or it's going to be less than or equal to the y value at the vertex. Okay? I know it's kind of quick. It's about 5 minutes, what it should have been. So I'm going to go over one of these with you real quick. Identify the things, and then I'm going to leave you to identify the rest on the next one, okay? The first thing we're going to look for is what is the vertex of this. And you got to remember, you count x's first, and then you do y's. So we are at 3. So our vertex is at positive 3, negative 1, 2, 3, negative 4. Okay? So we're going to write the value, x value of the vertex as a little equation. Again, all I'm going to write is x equals 3, because that's what it does at the vertex. And now I have written what? It's the thing called my axis of symmetry. Okay? Cool. Then we're going to look at the y value here. And again, the y value is negative 4. Notice the entire graph is above negative 4. And it also touches negative 4. So if we will write our y and our 4, and recognize that this entire graph is greater than or equal to that negative 4. Sorry, to negative 4. And we'll recognize that it is y is greater than or equal to negative 4. And we've written our range. So look what the vertex does for us. It gives us our axis of symmetry. By the way, that's this line. Look how it goes through x is 3. And then, of course, it helps us determine our range really quick. All we have to do is know if the graph is going up or if the graph is going down. The last two things we want to identify is the roots. Notice we're going through x is 1 and we cross the x-axis at x is 5. So I'm going to show you what we can actually do with that, okay? So the answers are x is 1 and x is 5. Now, there's a little thing we have to do, and you'll get this in other lessons. But if I take these two numbers and I create two factors, and instead of a positive 1, I make it a negative 1 inside of here. And instead of a positive 5, I make it a negative 5 in there. And I do my FOIL, which is x squared minus 5x minus x plus 5. And then I combine, I get x squared minus 6x plus 5. Okay, there's my equation. Now, I do want you to understand, let's see if my calculator will fit in here. I have to zoom out a little bit. I apologize. Okay, so let's look at the calculator. We see that this equation, if I calculated it right, is going to be x squared and minus 6x and plus 5. When I graph this, let's look at what it does. Okay, it goes through 1, it goes through 5. Look at my graph and look at this graph. They are identical. And I got that graph all because I took the two solutions, I converted them into proper factors, and then I FOILed them out. All right. Now, if you're stuck, here's another way you can create this. All right. Notice I have a point at 1, 0, so I can put in that point. I have a point at 3, negative 4. Does anybody remember what that was called? If you said vertex, you're correct. And I have a point at 5, 0. It's not a 0. I can go into stat and calculate. I can calculate, this is quadratic, so number 5. I can calculate a quadratic regression. And when I get done with it, let me zoom in a little bit. Oh, that's too much. You can see I wind up with 1x squared minus 6x plus 5. Hey, look, 1x squared minus 6x plus 5. Okay, so that's it. Pause the video right now. It's literally only going to take you like a few, maybe a minute or two to answer all the questions on the next problem. There's only one problem for you to practice today because you're supposed to write down your vocabulary and try to memorize that if possible. Anyway, in about 3 or 4 seconds, I'm going to kick off with answering all of this problem. All right, welcome back. It asks what the vertex is. That is right here at the high point. That is over 2 and up 1. So my vertex is at 2, 1. It says write the value of the x in the vertex as x equals. Well, the x equals 2 here. And x equals 2 is actually called the what? And I hope you had the axis of symmetry. That is this dashed line that splits the parabola right in half. All right. When using the y value, we can find what our range is. So look, notice that our highest value is 1, and then all of the y values go down from there. So all these y values are going to be less than or equal to 1. Look, 1 is the highest number, and then it's all the numbers less than or equal to 1. Of course, then it says find the roots. No problem. One of the roots is at 1, 0. The other root is at 3, 0. And if you went ahead and tried to calculate this out and find the formula, you would have to do x minus 1, because remember, you're going to take the opposite of these, and x minus 3. When you FOIL, you get x squared minus 3x minus x. Negative times negative makes plus 3. You should have had x squared minus 4x plus 3, and you would have had the proper equation. Hope you guys are having a good break. This is week 7. If we get to this, there's a chance of us coming to school or slim to none, I'm guessing. But if you have a question for us, be sure to check in with us during your Google Hangouts. Have a great day.